Okay, next what I am going to do is I am going to find this this indefinite integral here. So notice a lot of people, when you give them this kind of problem, what they will do is they will try to use integration via u substitution. Actually, you don't have to do that here, and it would not work anyway. For homework, try to figure out why it would not work. Okay, when you have something like this, you notice right away that you can actually multiply this expression in here by this expression x cubed. And that's exactly what we're going to do. Okay, so let me do that. So this is going to become the integral of x cubed times x to the fourth. That's just going to become x to the seventh. Then x cubed times x to the negative 3. That's just going to become x to the negative 3 plus 3. So that's just going to become plus x to the 0. But we know that x to the 0 is just 1. Then this, multiply this by this, so you get x cubed here plus x cubed, right? And now, of course, you have dx here. And at this juncture, all you do is you find the antiderivative of this stuff. And this is very easy to do. This is just going to become x to the 8th. Actually, 7 plus 1 is 8, divided by 8. Let me actually write it in standard form. So I'm going to have here x to the 4th plus x to the 4th divided by 4. Why 4? Because x to the 3 plus 1 is x to the 4th, and I divide by 4. Okay, and if you think in your head and you take the derivative of this, the derivative of this expression is going to be 4 times x cubed, and you're going to cancel the 4, so you're going to be left with x cubed. So you can check in your head that you've done the right thing. The same happens with this one. And then, of course, you have a plus 1, but when you take the antiderivative of 1, it just becomes plus x. And, of course, last but not least, you cannot forget the plus c. If you forget that plus c, you will actually lose credit if you're taking an exam. You will lose some credit for the question, some points for the question. Okay, thank you for listening.